So as a heads up, this is the last lesson in this unit. It's a very, very short unit. There wasn't much to it, okay? So this is the last lesson that we're going to do. So today is fundamental theorem of calculus. It's actually kind of important, okay? Fundamental theorem of calculus is for definite integrals. So let's review the difference. A definite integral has boundaries. So it would be like integral from 2 to 7 or something. Indefinite does not have boundaries, and that's where you can't get an actual answer for the area. You just put a plus C at the end. Do we understand the difference? Definite, boundaries, indefinite does not have boundaries, and you can't get like an exact answer. All right, so, throw the pencil here. If a function is continuous on A to B, and I hate that they do this, but I went with it because this is how it's always written. Capital F is an antiderivative for F on A to B. Then integral from A to B, lowercase f of x dx. And up until now, you either had to draw a graph and like find the area under it, or you can use Math 9 in the calculator, but I'm going to show you how to do it without the calculator. You do the antiderivative, which is going to be capital F, and it's f of b minus f of a. So it is upper boundary minus lower boundary. It should logically make sense. If you take where you ended up and you subtract where you started, do you understand that you get the area in between? Understand? Okay, so like it does logically make sense. So that's, what we did. So anyway, it's a way that you can do the problem without the calculator and without having to draw a graph, all right? So number one, first thing you do is the antiderivative. So what is your antiderivative for x squared? 1/3 x cubed. Now here's how it gets written. Such that, that's your such that bar, 0 to 1. So you got to be careful with your notation. Once you do the problem, you don't write the integral symbol in the dx. You did the problem, but you put that such that bar at the end. Now here's my suggestion. Do this every time, even if you think it's real simple. Don't be too proud to write this. You're going to do upper boundary minus lower boundary and write it out blank. Write it out blank. Because if it gets complicated, then you won't lose track of what you're doing. So first you're going to plug in 1 to this. 1 cubed. 1 times a third, 1/3. If you plug in 0, you get 0. Now, sometimes these get really messy. If they do, we'll just stop and leave it alone. But if it doesn't seem too bad, I want us to finish off the problem. 1/3 minus 0 is 1/3. And by the way, if you go back to the very first section I taught you in this unit 6, that is the one that we did. Do you remember I had the graph of x squared and we did our left, right, midpoint sum? And then we found at the end when I did it in the calculator, the answer was 1/3. Anyway, that's that problem. Let's try another one. 4x, what would be your antiderivative for 4x? 2x squared. You're looking for a function that if you did the derivative, you would get 4x. It's an antiderivative. Such that 0 to 1. And then write your parentheses, something minus something. It's upper boundary minus lower boundary. That's another one of those things you're going to hear me say 4 billion times. Upper boundary minus lower boundary. So if you plug in 1 squared is 1 times 2 is 2. We're struggling with the arithmetic today. All right, and then if you plug in 0, you just get 0, so the answer is 2. Again, if they seem fairly simple, we'll work it all the way out. If it's needlessly complicated, then we'll just stop. All right, antiderivative. We're going to do this term by term. For x squared, it would be 1/3 x cubed plus, all right, for just x, it would be what? 1/2 x squared minus, what would it be just for 1? Yeah, 1x, such that -3 to +3. So this one's a little bit more complicated. So draw out your parentheses, upper boundary minus lower boundary. And let's try and plug in 3. All right, ready? Stick with me this time. 3 cubed. 27, and then 1/3 of that is 9. Good. Plus 3 squared, 9, but it's going to be 9 halves. Don't you dare write 4.5. Minus minus what? 3. I have a reason. It's going to turn out better if you leave it as a fraction. All right, now we're going to plug in -3. -3 cubed -27, and then a third of that, -9, plus -3 squared is 9, +9 halves, and then you would have minus -3, so +3. This one actually won't be too terrible, so we're going to keep going. Okay, write out the first part, 9 plus 9 halves minus 3. We're going to distribute the negative through there. Everything will just switch signs. Don't be too proud to write it down. And then you can kind of group them. And that's why I said leave them as fractions. You can put all the whole numbers together and then all the fractions together, almost as though they're like terms. So let's do all the whole numbers. 9 minus 3 be 6 plus 9, 15 minus 3, 12. And then, oh, actually, what happened to the fractions? Yeah, they actually are gone. So 12 is your answer. Now, don't forget what you're actually doing, because what sometimes happens is when you start to churn these out, you forget what you're actually finding. In fact, let's review derivatives real quick. Derivative means slope. Integral means area. Okay, so let's look at this one. I'm going to need to rewrite this first before I do the problem. So I'm going to leave my integral symbol and my dx. I'm not doing the problem yet. I'm just going to rewrite it. How would you rewrite 2 over x squared? Good. 2x to the -2, and then we've got plus x. So now I'm going to do the antiderivative. You have to add 1 to the power. That makes it less negative. So it'll be x to the what? X to the -1. That means you would need a negative out front. So instead of 2, be -2. Good, perfect. Plus, and then what's your antiderivative for x? Good, 1/2 x squared, such that 1 to 4. Now let's talk about x to the -1 real quick. What does that mean? When the exponent's negative, what does that mean? Because I am going to erase and rewrite this so that it looks a little bit nicer for us. It's going to be a fraction. How would I rewrite this? It would be -2 over x. Good. When you have a negative exponent, it reciprocates. All right, draw your parentheses. Upper boundary minus lower boundary. And so if you plug in 4, what are you going to get? What would this first part be? -1/2, good. Plus 4 squared is 16, half of that is 8. And then if you plug in 1, you're going to get -2 plus 1/2. This one's not going to be too terrible, so I'm going to keep going. After this, I think they get pretty awful, so we'll like stop there. But distribute your negative sign. That's just going to flip-flop everything's sign. And then 8 plus 2 would be 10. And then what? Yeah, -1/2 and -1/2 would be -1. So 10 minus 1 is 9. Sometimes you have to be able to fight your way through it. Okay, these ones I think we'll leave alone, though, because these are going to be pretty awful. Look at number 5. Do you see how there's a 4 in the denominator? But there's not an x. Okay, I'm going to bring that out front. So I'm going to write 1/4 in front of my integral. Notice I'm not doing the problem yet. I'm just rewriting it. Sometimes you have to do that. You have to make it look a little nicer before you can actually work it out. So I brought that 1/4 out front. And then in here, this would be x plus, and how would I rewrite square root of x? Good. X to the 1/2. You guys are good with the fractions. Now we're going to do the antiderivative. So leave the 1/4 out front. Basically just evicted it. All right. Antiderivative of just x. 1/2 x squared. Good. Plus Now for x to the 1/2, if you add 1, good, perfect. And that means out front you would have 2/3. It's always the reciprocal. Such that 1 to 4, and you're going to do upper boundary minus lower boundary. And this one, we're going to just leave it alone because this is going to turn out like kind of awful. So for this one, you'd have 1/4 times, let's see, 4 squared is 16. Half of that is 8 plus 2/3 times 4 to the 3/2. If I made you do that though, listen, 4 cubed can't math today. What, you had a 4-day weekend and you don't know how to like multiply anymore? 4 cubed, 64. What's the square root of 64? Is 8. Then you'd have to do 8 times 2/3. That would be 16/3. 8 times 2 is 16. All right, and then we're going to plug in 1. So that would be 1/4 times, or if you're plugging in 1, that would be 1/2 plus 2/3. 1 to any power is just 1, so that's kind of convenient. And I'm going to just leave that. Like, this is the answer. So sometimes it works out kind of nice, and sometimes it's a complete disaster. All right, antiderivative for 2x cubed. Well, you would have to, bless you, you'd have to add 1 to the power, so it would be x to the 4th, bless you. That means you'd want a 1/4 out front, but there's already a 2 there. 1/2, good. Minus antiderivative of e to the x, e to the x, such that 1 to 3. Upper boundary minus lower boundary. Do not be too proud to write that out. Like, just blank parenthesis minus blank parenthesis. So if you plug in 3, 1/2 times 3 to the, I'm not even going to ask you guys what 3 to the 4th is, because does anyone know that one? It is a good job. All right. Minus e to the 3rd, whatever that is. All right. And then if you plug in 1, you're going to get 2 minus e. All right, here comes some trig. You need a trig function. It's one of the 6, and I'll give you a hint. It's not sine or cosine. I'll give you another hint. It's going to be negative. The derivative is cosecant cotangent. It's just going to be one of the trig functions. Which one has this as its derivative? Like, that's the answer. It is not secant. Secant and tangent are buddies. It is negative cosecant, such that pi over 4 to pi over 2. As long as you have it memorized by May, we're good. All right. So upper boundary minus lower boundary. Where is pi over 2 on your unit circle? Up. It's 0.01. Cosecant means you flip the y value. So 1 over 1, 1, but it's negative 1. Cool. Pi over 4 on your unit circle. It's in the first quadrant. What are the sides of the triangle? Square root of 2 over 2. If you flip square root of 2 over 2, it's just square root of 2. All right. But it's going to be negative square root of 2. No. Nope. Mm-mm. All right, find the area bounded by these graphs. Well, let's draw it real quick. What does e to the x look like? Yeah, I call it a swoop, all right? We have x is 0 and x is 2. That would be these. And then y equals 0 is the x-axis. So this is the area that we're finding. We're going to find the area of that. That's kind of cool. It's cool, guys. You find the area of like a curved thing. All right, so set it up. Integral from where to where? 0 to 2, good. Of what function? E to the x dx. What's the antiderivative of e to the x? E to the x, such that 0 to 2 Upper boundary minus lower boundary. What will that give you? E squared? Good. Anything to the 0 power is 1. Number 9, I was just looking ahead. We're just going to set this one up, because the setup is what's important about this. All right. So it says find the area bounded by those graphs. We are going to need to draw a quick sketch. You'll be okay, because you have to figure out where they intersect. This one, welcome back to Algebra 1. You're going to start at 0, 3. 1, 2, 3. And your slope is 3 halves. That means you go up 3 over 2. Up 3 over 2. It's not going to be perfect. It's just so you can like sort of see what's going on. It's like good enough, just so you can have a visual. All right, what is this other graph going to look like? Well, it's a parabola. So it'll be a U shape, good, and it's flipped, good, and perfect. Those are all the things I was looking for. So you're going to go up 8, and it will be an upside down parabola. Now, I'm pretty sure this is the intersection point, because they have to intersect somewhere nice. So try and plug in 2. If you plug in 2, 2 squared is 4. So it'd be -2 plus 8 is 6. So it's going to intersect right there. And then I believe 4 is where it, do you get what I'm saying? Like I can visualize this. 4 squared, yeah, 4 squared is 16, half of that is 8. So it's going to intersect the x-axis there. So it's going to do something like this. So the area that we're finding is this. And the reason it requires 2 separate integrals is because you have 2 separate graphs. So we're going to have one integral plus another integral. If you want to set it up blank, you can. We're going to have something dx plus something dx. And here's where they're going to split. Do you see how 2 is where it's going to split? Are you guys following me here visually? So what are your boundaries for the first integral for this part? From where to where is it? Good, -2 to 2. And which function is that you're underneath? Which one is it? Yeah, the line, right? The 3 halves x plus 3. And then what are going to be the boundaries for the other one? Good, 2 to 4. And do you see how for that one we're underneath the parabola? So the -1/2 x squared plus 8.